Hi, we would be starting our project now. First, we would install Termux and Termux API. We would open the Play Store now and search for Termux. So we click the install and wait for installation to complete. So it's done, and we will install the further Termux API. Same step as previously, just press the install button. Yeah, so both are installed now. So now as per step, we will be going to the opening the Termux console. So it's open. First we will do an apt update. So it's updating from the net, the required libraries. And next we will do an upgrade to install the package. So we will press the yes to confirm. So it's downloading the packages. So the next console is we will install the Termux API. Okay, so it's done. And we will install the Node.js now. So I am pressing the enter. So it's asking for confirmation. It will download the package of 95.1 MB. So it has installed the Node.js. So now we will install the Node-RED. So the Node-RED is being downloaded and installed now. So there are some warning and error message which we can ignore as it does not impact the functionality of Node-RED. Now we would launch the Node-RED. So as you can see, the Node-RED is started and it's running on 127.0.0.1 on port 1880, which is the local host. Now we will open a terminal parallel XTerm session and we will be checking our private IP in the Wi-Fi network which I am connected to. So as you can see, the private IP is 192.168.0.5 for my network interface. I will now try to open through the Chrome browser the Node-RED in my phone over port 1880. As you can see, the Node-RED page has started, and we can start with creating the flows and all the node modules for further actions. Now I would be checking my supported sensor list. So first command which I will invoke is termx sensor -L option to see all the sensors present in the phone. So these are all the sensors available at my phone, and we will be just concentrating on the light sensor which is present in here. So the next command is we will print the values of all the sensor by using -A option. As you can see, it's continuously polling for the sensor values, and since it's continuously polling, it will drain the battery fast. So now I would be shutting down this process using Control C. So the executable is terminated. Now I will make the polling interval to 1. So it's same, just we have to append -N that indicates the number of count we have to retry. And I will make it as 1. So for only for one time it will invoke. So as you can see, it has collected all the values and it has terminated. So if you need to get the command line option for this utility, just you can enter termx sensor without any argument. This will display the default help. As you can see, you can use -H-A, all the parameters listed here for further actions. So now I will be just filtering on my light sensor, which is termx sensor. For this I will use -S argument, -S, then the string name of the sensor. So it does a substring search. So I will be just invoking only like light sensor, which is a substring. So as you can see, it is continuously polling from only the one sensor, which is the light sensor, and it has matched using substring search. So the values you can see, like when I place my hand, the values are getting decreased, and when it's done, the values are getting increased. So this data we will be now sending into IoT for further actions. I am now stopping this command using Control C. So in this video we will be starting the AWS IoT setup. So we will first take the console from the main service window. We will press the IoT core console. So once you have the IoT core console, just go to the secure window. And in the secure window you have policies. So you create a new policy with some name. So arbitrary name I give is like IoT 1 plus. And under the action field, you just specify it as IoT star, And under the resource adherence field, just give it as asterisk so it accepts all the resources. And the effects you make it as allow and just create it. So now the policies is created. Now we will go to the manage tab. Under things, we will be creating a new IoT device and we will be registering it. So we will be like invoking the create a single thing step since we are only connecting one IoT device. So just give a name under this name field. So I will just give it as one plus. And here you have to create a new type. So I will be creating a new type like phone. Description you can give anything and just create a thing. Okay, since I have already created a phone, I will create it with some other name. So yeah, so the step got successful. Now I have to create a new group. So I will be creating a new group like phone 1 plus 60 and I have successfully created a group. Since I had one previous group, it is being shown here. So now this group is member of two group and you press the next. So here is where you have to create the certificate which will be used for your SSL tunnel establishment from IoT device to the IoT server. So just invoke create certificate step. So three certificates are downloaded. So just download these three certificates. So in this one, this is the private key and this is the certificate and this is the public key which we will not be using, mainly this one. And one more thing we need is the root CA certificate to validate the change. So just press download and download the Amazon root CA one using save as option under Firefox. Yeah, so this is the certificate. So you can see I am storing it under here. So now I will be like copying all the certificate to one new folder. So these three files are selected. So these three certificates are there. I'll just rename the file to like certificate.pmcrt.txt and this one as private. So these two files are the major files which we need and along with that the CS root CS certificate also to validate the change. So even that certificate is copied here. So after this chain you have to activate it. So the certificate is activated and we have to attach to the previously created policy. So this is my previously created one. So I will be attaching my certificate to this one and I will register it. So this completes the step for part 6. Now we would be launching the Node-RED instance from my laptop. So I will be entering the private IP of the phone, which is located at 192.168.0.5, and the port of service is where the node-RED is running over is over 1880. So it has launched the node-RED instance. Now I will be importing the pre-created flow from the PDF. So I have copied it and I am going to paste it. So I have selected the import tab, and in the import tab I am copy pasting that content, and I am pressing the import button. So as you can see, there are 7 nodes and 1 flow which got imported, and it has created a new flow instance named as 3. So here you can see the different modules like the 7 nodes which got created and the interconnection wiring between them. So this is how the node-RED works. So this is inputting the timestamp, this is invoking the system command on the phone, this is converting it into JSON, this function is parsing it into and getting the data, that is the value from the output, and this is formatting to the stream which will be required for IoT, and this module is pushing the data to the IoT. It can support like HTTP post method, then and other methods. And these are the payload which we have redirected so that we can get it in the debug window console, as you can see there. So as per the instructions, now I will set the system command which needs to be executed. So I have copy paste like made this command earlier. So this is the termix sensor command which we have seen earlier, and this is my string, the name of the light sensor in my phone, and I am repeating it for 1 time. So I just copied it and I have pasted in the command field, and the mode is like when the output of the command will be passed to the next module like the JSON module, and so this option is selected for that, and I have pressed done. So now you can see this is reflected. So in the same way we have to modify get the number function also as per the light sensor, like the name of the light sensor present in my phone. So I would be copy pasting this content. So I copy paste the sensor name here, so it's extracting the values field as we have seen from the previous output how it comes. So this value will be passed to the further connected nodes. So this is done. So now I will be pressing the no, before pressing the deploy button, we have to change one more module to communicate to the IoT device. So I will be modifying the HTTP thing. So here we have to give the endpoint of the AWS server, which we can get from the AWS web page. So from this web page, just go to the settings tab where you can see your endpoint. So just copy this endpoint and paste it in the node-RED. And as per the instructions, just copy this one and replace the my topic with whatever topic you require. Like I'll be changing this to my name, my phone name, OnePlus. So this thing you have to put your name, and the QoS is of type 1. And I will be also be enabling the SSL session, which that's why we have downloaded the certificates previously. And I will be now loading the 3 certificates. So these are the certificates. So this is the private key, this is certificate, and this is the CS certificate which is needed. So I have just pressed upload. So I have selected this certificate previously in one path as we have seen, like certificate cell. So I will go to that thing. So this is the certificate and this is the private key, and now this is the Amazon root CA. So this is done and just press add. So every configuration is done, then press done for completing this node configuration. So this is done and just press the deploy button. So the node got successfully deployed as you can see from here. So in the previous step we had a minor issue, like I missed to put the port number properly. So I have put the semicolon this one and press the done. And I have to deploy the new changes like by selecting modified nodes and pressing the deploy. So it has successfully deployed, and as you can see the PID is being started and it's sending the request out, and you can see when it's successful the blue thing will be highlighting here, and you can see the message which has successfully flowed to the AWS server. As you can see now the values are getting populated to the AWS server, and see like this, and even there are some errors which is mainly occurring because this command is hung due to some other application using the sensor, and the timeout default timeout is about 1 second, so it kills and there is no output in std out. So that's the reason for this error, and when it's successful you can see that tray is visible on the output. So we will be now checking on the AWS the data. So we'll go to the test tab and we will subscribe to the topic. So my topic name was OnePlus. So I will put this one and I will subscribe. So you can see this one is there, and here we should be seeing the message. So these are the things, light sensor value. So if I just place my hand on the sensor, the value will become 0. So as you can see the values are getting reduced and it's coming to top also. So these were the values which was sent from the server. Here we would be creating a new AWS instance and would be installing the things board on that instance. So let's see the procedure which needs to be followed. So I am just launching a new instance. So since things board require like Ubuntu, I will select the Ubuntu platform for this. So this is the Ubuntu server which is available under free tier. So I will just select this over x86 platform, and it has 1 GB memory and 1 CPU. So this is same thing, and I am role I have like predefined thing, pre-created one, so I have assigned that. And the storage which I allocate is of 8 GB. So these are the things, and now I will launch the instance. So now this is for the SSL connectivity, which you can do over PuTTY or SSH session. So I'll be just log creating this one. So this is the security file, PEM file, and I will just launch this instance. So this instance is now pending, and once it's up, we can connect to it. So now we will be logging to this instance through the putty. For that, first we need to convert the previously downloaded private key. So this was the previously downloaded private key which we had, and we will be using puttygen to convert into a putty recognizable format in .ppk extension. So I just opened the putty session and I'm giving the DNS IP of my instance. So this is pasted and I am creating a new name to save this instance under putty. So this is saved, and now I have to give the private key to auto login. So this was located at here, so I have just given the path. And one more thing we have to do is the default instance name, which would be Ubuntu at the rate. So I will just load and I will just give this thing and I will open the SSH session now. So if everything goes fine, I should be getting the prompt. Yes, I have got the prompt. You can see it's running in the Ubuntu server. Now we would be installing Thingboat on this instance. So first we will be installing the Java. So let's upgrade the package. So it is downloading the fresh repository list from Ubuntu servers. So now I will be installing Java onto it. So it is asking for confirmation, so I am just giving yes. So Java installation is completed and I will be just verifying like how many Java instance is there and what is the default instance path. So as per this thing there is only one instance and it's the default, which is the one which we recently installed to this. To double confirm, I will just be checking Java version also, which is proper as per the expected thing in the tutorial web page. Now the prerequisite for Thingboat is installed. Now I will be getting the Thingboat package, and here we are using the Thingboat professional package, which needs a license key. And this has installed. So it is installing the Thingboat now, and it has completed. It now we need to configure the license key, which I will be doing in the background in this Thingboat conf. So the step 3 is done, and now we will install the database which is required. So I'll be installing PostgreSQL database. And again the same steps as previous. So the update of the package repository is done, and now we'll be installing the database PostgreSQL. So it's completed, and we will be starting the service. So the service is started. Now we have to create a database, and for that we need to change the default password of Postgres. So we'll be invoking this command. We'll be logging to Postgres user, and we'll be taking PSQL. So these are the windows. So to change password, you just give this string. So it will ask for new password. So I am setting the password. So password is set, and now I am exiting this control window. So it's done, and now we'll create a database on this. Since the service is running on localhost over port 8080, we are connecting to that. So again, the password which I have set previously using the commands, I am giving it here. So it has logged in, and now I am creating the database instance which is required for things boot. So it's done. So it has created the database, and I am exiting this control window. Then we are changing the configuration file of ThinkBoard. I am doing it under super user. We have to paste this configuration into the database configuration file of ThinkBoard. Okay, before doing that, we have to exit this one. So we will be doing Control D to come back to the Ubuntu prompt. So it has logged out. And now we would be opening the file and pasting this configuration there. So the configurations are updated. And again, one more configuration we have to add because we have only 1 GB RAM in the instance. So again, one more option enabled. After this, we have to execute this command to launch the ThinkSport demo web GUI. So this will do that for us. So it will be creating three types of users in the database, which is visible here, like sysadmin, tenant, and customer. We'll be using tenant to communicate to our IoT devices, and you can see the port on which the ThinkSpot will start also. This localhost, we can enable the firewall in the AWS server so that we can contact the DNS IP, and through that we can communicate to our AWS instance. So as you can see, the installation of the script is being done and it has successfully installed. So this is being done to start the things board. So previously we have started the SQL database. So now we have started the things board. So the SQL database is running services under different port, which you can see by executing this one. So that's it. So now we have to enable the firewall rule. So for that I will be going to security groups and you can see I have launched under wizard 4. So I have to add a new rule to inbound session. Now it's accepting only SSH. So I will be adding for the port 8080 also. One more rule to accept communication from all IP ranges. So this is saved. So now I should be able to contact my instance. So let's see. So previously we have seen the session is not getting open because the Thingsboard service has failed. So this is because the license has exceeded the capacity. Like previously I have installed this on a different instance. So I will be now switching on to that because only one instance I can launch with this license. So I have logged into a new instance, EC2 instance, which I have previously installed, used with this IP, and you can see the instance. The instance is running here with this one. So I'll be copying this value to launch the service. And moreover, I have enabled the security group also to allow this port. So this is visible here. So now I will be launching to this one. So this is the port. So this is the one which we have copied. Press login. So I will log in with this name. Tenant at this one and the password as tenant. So it's logged in. So you can see the professional version differs from the free version in this thing. So now I will be creating a new asset which is as same as the previous thing and one more device group also under it. So let me delete the previous old instance. So these instances are deleted. Now I will create a new instance. So this is grouping. So now I have created a primary group under asset. Now I will create a new device group also similarly. So this one is also created. Now I will add all the devices under this group. So I will be pressing the add device button. So this is my phone name which I am giving and the device name which you can give anything and just you press add. So here if you want you can add multiple devices under this thing. So here I am again creating one more asset under this group IoT projects. So you can just press this and give some name, and asset type you can give this one and just add. So you can add multiple assets under this primary main group of IoT projects, as similar as what we did for this device grouping, where you can add multiple devices under this. So now we will add a relation between the asset and device, which we can do in this tab. So you just press plus and just give some name. So this is done. Just give some thing in the device type. Just give some other string. Target type as device and just select the device which we had and just create with add. So this one is got created. So now as per tutorial we can see that we can see push the data by simulating through curl, or we can do it by the IoT device which will push the data. So now we will be moving to device group, and as per the installation steps you can see we need to retrieve the access token, which will be visible under the things port devices tab. So just go there and just click this one to get your access token. And the next subfield which we need is the host IP, which anyway you know it's present under the things port link itself. So this is the DNS of our AWS instance. So I will be just simulating this first time over the curl API as per the tutorial. So this is the access token which we had and the host name which we need to change. So the host name we will change to this one. So these are done. So we will configure again as per the tutorial. So everything is correct. So we have done and we will just press the enter. So it's like it has successfully sent the data. So it should be visible under the latest telemetry data. So you can see the value which I sent was 30 with the key as temperature. So the same thing is present in here at this time. So this is how you send the message to the ThingsPod instance using the curl. So here I have used HTTP post method. Now I will be simulating this same thing over the actual IoT device, that is through the phone. For that we will again relog into the Node-RED instance, and as you can see we have to change it here. So now we are switching over to the ThingsPod instance. So now you have to give the ThingsPod API here. As you can see this, and API v1, the same thing which you gave in the curl command, and the access token, which again you can get it from here, this field, and the details. So again give that value here. And yeah, so this is the endpoint which you have to post. So I am replacing this thing with the actual instance location of the things port, as you can see. So it's using HTTP or EC2 instance or port 8080 with token ID this and endpoint as telemetry, and I have disabled the SSL, and I have pressed the done and selected modified nodes and click the deploy. So it will be now sending the data to the ThingsPort instance instead of the AWS IoT instance. So you can see that the data is being transmitted because you are getting this means the data was successfully posted into the HTTP server. Now we will be checking the send data in the ThingsBoard instance. So let's move to ThingsBoard panel, device group, IoT 1 plus lab 7 and the device. So latest telemetry data. So you can see the field like previously which we have seen in the AWS IoT instance, that is date and light sensor gets populated here, and this was from the curl simulation. So I will just change this value so that you can see it's getting changed to 15 to 18, and if I place my hand it will get converted to 0, so 5, and again it will come back to higher value. So the values are getting properly passed into the ThingsBoard instance. Now we will create a dashboard instance which will show us an XY plot of the light intensity value versus the date. So now we would be creating the dashboard to show the XY plot. So first we will move to dashboard group and create a group to collect all the dashboard instance. So let's name it as some IoT dashboard and some description you can give. So it's created, and under this now we have to add the dashboard. So again some arbitrary name I'm giving. So it's given and it's added. Now we will open the dashboard. Now you have to configure the widgets under it. So first stage you have to create an alias. If the alias is not created, then in the latest stage you cannot find the device from which the data needs to be taken. So this is an important step. So again I am giving some arbitrary name. Filter type you have to select it as device, and device type is IoT. So it's done and it's saved. So the data is now saved. Now you will add a new widget. So it's of type chart. So chart is getting loaded, and this is the XY plot. So you are using real time in the x-axis. So here you can find your thing, which is the alias which we created. And this is the value which we need to plot, which is of light sensor. So just add it. So now as the values get pushed from the IoT device to the EC2 instance under ThingsBoard, it will start showing. As you can see, the values are getting pushed and the plot is being averaged. So this is the graph with the current value which it is pushing, and I am changing the light intensity value, making it up. So as you can see, this averages the plot and all the values are being displayed. So yeah, so this once the values remains, if it's remaining constant, it will be a straight line. So yeah, so that's how it's fair. So as you can see, as the data gets populated, if it remains constant, it will be a straight line. And once again, if I change the value, it will go down. If I again move my hand, it will again come up to the constant value. So this concludes the Lab 7 presentation. So thank you everyone.